During World War II, the British found that the probability of bombers being lost through enemy action on a mission over occupied Europe was 0.05. It is reasonable to assume that missions were independent. Take AI to be the event that a bomber survived its ith mission. Let me first write down the probability of safe. How do we find the probability of safe? We know the probability of lost. It is given. It is 0.05. And we know the complement rule. Probability of A equal 1 minus probability of A complement. So we can write probability of safe equal 1 minus probability of lost. We know the probability of lost, which is 0.05. Therefore, probability of safe is 0.95. That is the probability of AI. Go to the first one. What is the probability of surviving two missions? That means they are asking probability of A1 intersection A2. Again, A1 is the surviving from the first mission and A2 is the surviving from the second mission. Right. Now, how do we find this probability? It is reasonable to assume that missions were independent. Therefore, we can apply probability of A intersection B equal probability of A times probability of B multiplication rule. I explained this in the last video. A1 and A2 are independent. We can write probability of A1 times probability of A2. Then we know probability of AI is 0.95. So answer is 0.9025. Then go to the second one. What is the probability of surviving three missions? It means probability of A1 and A2 and A3 surviving each mission. Again, we know this. We can apply multiplication rule for the independent events. Therefore, we can write this as probability of A1 times probability of A2 times probability of A3. We know probability of AI 0.95. Therefore, answer is 0.8574. The third one. In 1941, the tour of duty for an airman was established as 30 missions. What is the probability of surviving 30 missions? Again, we know they are asking intersection of 30 events. Then, how do we find it? We know A1, A2, A30 are independent. Therefore, we can apply multiplication rule to this case. 0.95 30 times. So, answer is 0.2146.